We'll have to use a different technique if we have more than one fraction on either side of our equal sign. So to do that, we're going to eliminate the denominator and just get rid of the fractions. So let's look at our first one, 7 over x minus 1 minus 5 equals 6 over x squared minus 1. So we're just going to multiply this entire equation by something that will get rid of all the fractions. So to get rid of this denominator, we would want to multiply that by an x minus 1. Minus 5, we don't have anything to worry about there. And then 6 over x squared minus 1. We'll factor that. So that factors into x minus 1, x plus 1, so that we see what factors we need to multiply by to get rid of that denominator. So we need an x minus 1. Well, we already have that, so that's going to be taken care of. And then we also have an x plus 1, so we'll multiply the whole thing through by an x plus 1. Now we have to take these two factors and send them to every term in our equation. So when we take this whole thing and send it across to 7 over x minus 1, the x minus 1 will cancel with the x minus 1. And so we would just be left with 7 times x plus 1. When we send this whole thing to the minus 5, nothing's going to cancel. And so we're going to have minus 5 times x minus 1, x plus 1. And then that is equal to, when we send it here to the 6 over x squared minus 1, both of these factors cancel. And so we are just left with 6 on that right side. So then we'll FOIL everything out, combine like terms, set it equal to 0, and we'll have something that we should be able to solve with techniques that we've seen before. So we would have 7x plus 7 minus, I know that x minus 1, x plus 1 multiplies to x squared minus 1. So if we distribute a negative 5 in, we're going to have minus 5x squared plus 5 equals 6. So on the left we have minus 5x squared plus 7x plus 12 once we combine like terms. And I'm going to move everything to the right. I'm going to add everything to the other side. So add this one, subtract 7x, subtract 12, so that my x squared term is positive. So moving everything over to the right, I'm going to have 0 equals a positive 5x squared minus 7x, and then minus 12, so 6 minus 12 is a minus 6. So to factor this, this is one of our not as favorite cases when we have the 5 in the front, but we know we need 5x and x. We're multiplying to a negative 6 and adding to a negative 7, so we want to get one of the factors of 6 multiplied by 5 to add with the other factor to a negative 7. It looks like this will be minus 2, because that would get us to a negative 10x, and then plus 3 over here, because that would get us the negative 7x. So we would have minus 10x plus 3x gets us that negative 7x. 3 times the negative 2 is the negative 6. And 5x times x gets us the 5x squared. So then to finish finding the zeros, we take each of these factors, set them equal to 0. So 5x plus 3, if that's equal to 0, we would subtract 3 and divide by 5. So that gets us a negative 3 over 5 for 0. And then from x minus 2, we get x equals a positive 2 as a 0. So those are the two zeros. And again, we should check if those give us a 0 in the denominator up here. But it looks like we're good. So we'll move on to the next one. So here we have 6 over x minus 3 equals 8x squared over x squared minus 9 minus 4x over x plus 3. Again, real quick, we maybe just want to factor each of the denominators. X minus 3 is good. X squared minus 9 goes into x minus 3, x plus 3. And then x plus 3 is good. So the things we need to eliminate are an x minus 3. That takes care of the first one. In the second fraction, x minus 3 is covered, so we need an x plus 3. And then in our last fraction, we have 4x over x plus 3. That x plus 3 is taken care of. So we're good to take and distribute x minus 3, x plus 3 to all of the terms. So when we send that to the first term on the left side of our equal sign, the x minus 3's cancel. So we'll have 6 times x plus 3 equals, when we send it to the second fraction, the 8x squared over x squared minus 9, both the x minus 3 and x plus 3 will cancel, so we will just have 8x squared, and then minus 4x times x plus 3 cancels, so we have that x minus 3 still, so 4x times x minus 3. Multiply things out, 6x plus 18 equals 8x squared minus 4x squared plus 12. Don't forget to distribute that negative, plus 12x. Sorry. Okay, does that look good? Combine like terms, 6x plus 18 equals a 4x squared plus 12x. Subtract our 6x and the 18. So 0 equals 4x squared plus 6x minus 18. We can make that a little bit simpler to factor. There's a 2 that we could divide out in every term. So if we just divide both sides by 2, that would leave us with 0 equals 2x squared plus 3x minus 9. And that's maybe a little bit easier to try and factor. So we're going to have 2x at the front and an x in the other one. We need to multiply to a negative 9, but add to a positive 3. I think minus 3 and plus 3 will get us there. 2x times x gets us to 2x squared. Minus 3 plus 3 gets us to minus 9. And then 2x times 3 is 6x. Minus 3 times x is minus 3x. So 6x minus 3x gets us the 3x that we want. So set those factors equal to 0. 2x minus 3 equal to 0. We would add 3, divide by 2. So positive 3 over 2. And then our 0 from x plus 3 is going to be a negative 3. Check and see if either of those give us a problem. It looks like x minus 3 does. Or sorry, x equals a negative 3. If we plug in a negative 3, we're going to have 2 spots where we would be dividing by 0. So that means x minus 3 is an extraneous solution. So all we have is x equals that 3 over 2.